Okay, I will briefly discuss what is slope and intercept and how they are related to important topic of writing equation and sketching the graph of that particular equation. So if we try and understand about slope, what is slope? Slope is when we are standing on a smooth surface. If it is absolutely plain and it is not inclined on any side, the slope is zero. For example, if we place a ball on that particular surface, it would not move in this direction, or if I try and plot it or sketch it on 2D, if we place a ball over here, it would not move in any direction if the slope of that particular plane is 0. But what if there is a slope? The ball, depending on the slope, would move either on left or towards right down the slope. So for the case when the slope is with the x-axis, if the slope is when we increase x and the slope is going up, you have to go up from this side to this side. And the second trick to it is, if we know the theta of that particular plank or the plane, if the theta is written as it is less than 90 degrees and it is greater than 0 degrees, then in that case tan of theta would be between 0 and infinity, but it would be positive. So for tan of 0 it is 0, for tan of 90 it is. So in that case, because for considering ASTC, all are positive, sine is positive, tan is positive, and then cosine is positive in this quadrant. If it is like this, if the angle is taken this one, or if we take the angle to be this one, in both the cases tan would be positive. And since tan is positive, we consider tan theta as the slope, written as m mostly, so the slope is positive. But the case when the slope is intended as if it is in the second quadrant or the fourth quadrant, anywhere, so theta in that case is greater than 90 degrees and less than, so because it is from 90 degrees, it's greater than this, and it's less than 180 degrees. It is less than 180 degrees. So it is between 180 and 90 degrees. We can also write it as if it is greater than this and less than 180. We can also write these as pi by 2 theta and pi. Of course, we can write the same thing for this particular angle. It could be over here, or it could be over here, or it could be all the way from here. So in both the cases, in all these cases, it is either in the second quadrant or the fourth quadrant. In both these quadrants, tan is negative, so the slope would be negative. But what if this is the condition? Then since tan of 0 is 0, we would say there is no slope. And when the line is like this, slope is undefined because tan of 90 is undefined in that particular case. So that sums it up for slope. For intercept, we say that it is for this particular case passing through the origin, so there is no slope, no intercept. But what if it does go through somewhere in here? So it is crossing this point. This point x has a value, but y is 0. And for this particular point, x is 0 and y has a certain value to it. In a particular case, when we define the slope, we use this angle, and corresponding m would be tan of this angle. And whenever we have intercept x0, if I have, for example, another line of the same slope, I can go through here, I can draw another line through here, I can draw another line. So I can draw infinite number of lines going through here. But for all these lines, the intercept is different. So for the same family of, for the same slope, there can be a family or a range of lines. But if we restrict the intercept as well, we would have only one line. If we restrict the slope, we restrict the angle with the x-axis. And if we restrict at the same time the intercept, then when we fix it as y is equal to mx plus c. So this is slope intercept form. For the first case, when we said that we can have 2 points and then we can connect the two. So the first point, let's suppose, has coordinates x1, y1, and the second one has x2, y2. So the equation in that particular case can be written as y minus y1 by x minus x1 equal to the tan of theta. We remember from trigonometry that for that particular case, this is the difference between x1 and x2, and this is the difference between y2 and y1 and y2, and this is angle theta. This is right angle triangle in that case, so this is the same thing, but we can write it as y minus y1 equal to m x minus x1. If we write it in terms of y, then the intercept would be y1 and sum of mx minus 1. So it would turn out to be y equal to mx plus y1 minus mx1. So this whole term becomes the intercept. This is the same as we had written in here. But if we write the same equation in terms of the 2 points, it is called something different from this one. It is written in a different way because we are considering 2 points. In this one we are considering just 1 point. So what we would write in this particular case, for this one, we would write that the slope, whenever we have a point xy over here, we have x2 y2 here and x1 y1 here. So the slope of the points y minus y1 and x minus x1 is equal to y2 minus y1 and x2 minus x1. So it turns out it boils down to the same equation as something like this one. So this is something I had to wanted to share with you guys. Until next time, Allah Hafiz.